We look at workbook page 121, finishing talking about summarizing data distributions. So the first question, they want us to find the median for the data, and what does the median indicate about the data in this problem. So if we look at the box plot here, the median here would be 15. Again, we can tell that it's always, we have kind of, if you think about in our box plot or box and whisker plot, we have kind of two boxes, and where they meet is at the median. So we could say our median is 15. When we talk about mean we call average a lot of times. With median, we don't necessarily consider it to be an average, but what we could say for median, we could say it's kind of like a typical value. So we could say the median is 15, which means that maybe quote unquote typically a class, or let's say there are 15 students in each class. That have a dog. Okay, and again, if you look at your box plot or box and whisker plot, I mean, we've got a pretty wide range here. Let me move that up. We've got a pretty wide range here. We've got all the way from 3 students in a class that have a dog all the way up to 27 students in a class. But again, we're just taking that median and using that to kind of give an idea about how many students have a dog. So interquartile range, we're looking at the difference between our first quartile and third quartile, or lower quartile and upper quartile. So in this case, lower quartile is at 9, upper quartile is at 21. So interquartile range, if we subtract 21 minus 9, then 12 would be our interquartile range. And then if we look at number 3, describe the shape of the data distribution. If we look at this box plot, we can see that the box plot is symmetric. Okay? It is symmetric. In other words, if we fold it right at the median, then the two sides would match up with each other. Alright, now if you look at number 4, it says if a dot plot were used to display the same data, what would it look like? And initially, just thinking about this, I might think, well, the box plot is symmetric, then my dot plot must be, that it would have to be symmetric also. And the answer is not necessarily, actually, but I would say it's probably should be at least roughly symmetric, because we have equal amounts of numbers between 3 and 9 as between 21 and 27. We have equal amounts of numbers between 9 and 15 as we do between 15 and 21. equal amounts of numbers, it doesn't mean we're exactly, for example, going to have the same number of 9s and 15s. Does that make sense? It's just that between 9 and 15 we have a certain amount. Let's say there were 10 numbers between 9 and 15. Then there would be 10 numbers between 15 and 21. They could be split up a little bit differently though. We look at number 5. We have 25 students in a math class that took turns flipping a coin 20 times. The dot plot shows the number of times the result was heads. What do any clusters and gaps in the dot plot tell you about the likelihood of the coin landing on heads? So the first thing we're going to do, they're just talking about clusters and gaps. We're just going to look at this dot plot and see if we have any clusters and gaps, and if so, what are they? So as far as clusters go, clusters generally we've got multiple values that happen. Usually is how we look at this. So you might say 9 to 11, or maybe you could sneak in and say 8 to 11 there. So first of all, we could just answer the question about clusters and gaps. So we could say we have a cluster from maybe 9 to 11. And one thing, if you'll notice about that cluster, the 9 to 11, that's located in the middle of the dot plot. Okay, so with no large gaps. So the gaps, there's no gaps, that's not really necessarily telling us anything then, just that the numbers are pretty close together. And then since we got a cluster there, we could say with the cluster, we only have one cluster, so we could say this tells us that the coin is likely to land on heads around 9 to 11 times out of 20. Okay, if you remember at the beginning of the problem, they said that they flipped the coin 20 times. These were the results. So about 9 to 11 times out of 20 that they got heads, which is what we would expect, somewhere around there, because you know, half of 20 would be 10. We would expect about half the time to get heads and half the time to get tails. So part B asks which measures, if any, would be best to summarize the data. Measures, what they're talking about would be the measures of central tendency. So that would be either the mean or the median. And so if we look at this one, like we talked about, we don't really have any outliers. Because we don't have any gaps, we don't really have any outliers. So the best option probably to summarize this would be the mean and the MAD, or mean absolute deviation. Okay, if you remember, we talked about the other day, if we didn't have outliers, then these would be the things we would use. Okay, again, since there are no outliers. Also, your book talks about if we have a cluster in the center and it's symmetric or roughly symmetric, then we'll use the mean and MAD. So that would be another way to know to use those measures. Okay, we look at number 6. The school nurse asked 15 parents how many hours they spent exercising each week. The dot plot displays the data. So what do any clusters and gaps in the dot plot tell you about the exercise habits of the parents? So again, first of all, we're going to look at whether we have clusters or gaps, and then we'll talk about what those tell us about what's happening. So if you'll notice here, kind of on the extreme ends here, you could kind of argue about some gaps here. So we could say that this is clustered, or we have clusters from 0 to 1 and 8 to 9. And then we'll look for the gaps. So for our gap, we've got a gap kind of in the middle here. Gap in the middle, or gap in the center, we could say. So common sense kind of then, as far as our what that's telling us. Is that we've got kind of some extremes happening here. So we could say parents, well, maybe we could say many parents exercise either 0 to 1 or 8 to 9 hours per week. Okay, and maybe by their exercising is actually what they consider exercising. A lot of things just we do in a typical day, we still are getting some exercise, regardless of, you know, necessarily going to the gym or something like that. So for part B, they want us to tell which measures, if any, would be best to summarize the data. There's a couple routes we could take here. One route what the book says is that they say none because there are no data in the center. If you go back though and look in your book on page 496, it talks about if something is not symmetric, and we could argue that case. We could say the median and interquartile range, IQR, since it isn't symmetric. Okay, so obviously you don't give both of these answers, but one or the other, probably either one of these answers would be acceptable. Technically, the second option is really what the book kind of guides us to do. Not symmetric, let's use the median and IQR. Again, mean and median, though, are measures of center, so if we don't really have anything in the middle, we've got all this extreme stuff happening. For us to say on average, you know, they exercise 4 to 5 hours a week, but really nobody's exercising 4 to 5 hours a week. You know, on average or typically somebody, you know, exercise that amount. It seems kind of weird because there's nobody that's actually doing that. Does that make sense? We look at the next part here. It says in 7 through 11, use the data to answer the questions. Number 7, they're asking us to find the median and the mean, and then find the interquartile range. That'd take a little bit of time for us to do with all the numbers. So just recall, if you're going to find the median, first thing you need to do is put the numbers in order from least to greatest, okay? And then find either the middle number or the average. I'm going to go ahead and just tell you for time's sake what is going to happen here. The median ends up, if we work it out, would be 79.5 or 79.5. The mean, if you remember, for the mean, we add all the numbers and then divide by how many numbers there are. So the mean, if we work that out, ends up being 80. And then the interquartile range, remember interquartile range, you got your median, then you find the median below the median, which is your lower quartile. You find the median above the median, which is your upper quartile, and you subtract those. Interquartile range ends up being 7. And again, that just gives us an idea of how spread out the middle 50% of our numbers are. Okay? So then if we look at this on number 8, it says what would be the preferable measure of center, the median or the mean. Again, that kind of went back originally to whether we had outliers or not. So if we look at this chart, let's see if we would consider us to have outliers. So if we look at the numbers, kind of could maybe argue that 91's a little bit on the high end, which 89's kind of right there with it. So if you would argue those to be outliers, remember, if we have outliers, probably the better choice for the measure of center would be to be the median. So one argument, you could say the median, since 89 and 91 are outliers. Okay, and again, that's kind of a borderline call there. A little ambiguous. Not a clear cut, you know, these are definitely outliers type situation. So you could argue, if you consider those not to be outliers, then you could say the mean because there are no outliers. Alright, so you could go potentially either way. This is the way the book went, so just mentioning that to you guys, that, you know, maybe slightly the better answer on this question. Number 12 asks, which statement about the pet fish data is true? So we're looking at how many pet fish students own. And we're just going to think through these answers, think about if they make sense or not. So A says the median and the mean are the same. So first thing, we would have to figure out what those are. Nice thing about this dot plot is that the numbers are already in order for us. There are actually, if you count up all the ones here, there are 11 of the ones. There are 9 of these 2s. Obviously 2 3s and 1 4. So if we're going to find the mean, 11 ones would be 11. 9 2s would be 18. we do 2 times 9. 2 3s would be 6, and a 4. And 11 plus 9 is 20, 21, 22, 23. We have 23 dots, so 23 numbers altogether. So if you add that in our numerator, that would be 39. So 39 divided by 23, well, that's not going to go in very much. That's only going to go in one time, and we'd have 16 left out of 23 would be our mean. So the mean is 1 and 16 23rds. The median, since we only have whole numbers here, either the median is going to be just a whole number as well, or if we have somehow where it's the middle of 2 whole numbers, it would be something and a half, for example 1.5 or 2.5. As it turns out here, we know we have 23 numbers, so the if you think about 23, we would have 11 numbers on each side, would be 22, and then one number in the middle would be our median. So the 12th number, so actually whichever you consider, the top or the bottom two, probably the bottom two I guess, that first 2 would be our median. Okay, so obviously the median and the mean are not the same. B says a good representation for the center of the data is 2. Well, our median is 2, so if we think about this, we'll come back to that one in a minute. I'll talk more about that. C, the data are symmetrical. Obviously this is not symmetrical. And D, the data show that most students have 3 or more fish. Well, only 3 out of 23 have 3 or more fish, so that doesn't make sense. So kind of just even reasoning this out, B is going to have to be our best answer choice. And this actually goes back to something we talked about earlier, is that if the data are not symmetrical, then it's said to use the median and the interquartile range. So that's the case here. It's not symmetrical, so we use that median, which is 2. And then if we had a box plot or box and whisker plot, we could use the interquartile range as well. So this gives you an idea of how to summarize data distributions.